In electronics, simulations play an important role. As we will learn throughout the course, most of the components that we use and we buy have tolerances. For example, we buy a resistor that has a 5% or 10% tolerance. Same thing with capacitors. We have the same issues with transistors, diodes, almost every component. With some other components, especially when we are dealing with digital electronics, it's not as much an issue as for analog electronics, but still it's very easy for a component that we buy that it can be really faulty. So the first step that we usually do in trying to design something is build it on a computer first. When you build it on a computer, you can test all the alternatives. You can test the outputs, and that way you'll be aware of what you should expect as an output. And when some things do not work, figure out alternatives to get it to work. Once you get a project to work on a simulation, then you build it on a breadboard, and we'll talk about breadboards later. Test it out, and then if that works, then you move to the position where you can actually build and solder your circuit. Now, as I was just mentioning, simulations is not just for the classroom. They are an integral part of the electronic engineering process. That means not only physics classes, not only engineering classes, it's the whole electronic engineering process that includes factories and whatever you can think of. Now, most industries and a lot of engineering departments, actually probably most of them, use usually commercially available products for simulations. And these usually rely on an algorithm that was designed at Berkeley that's called SPICE. And SPICE initially was a command prompt type of design, and you give it essentially instructions in the form of text, and you get the output of the simulation in the form of text as well. The commercial products take that engine and build a graphical interface around it, and the graphical interfaces vary, and then also the commercial products vary by including the specs of many of the components that are available in the market these days. There are lots of SPICE products. Usually you'll find SPICE as part of the name that are available in the market. Some others do not necessarily have SPICE in the name, but they take advantage of the algorithm. I'm not sure about the ones we'll be using in this particular course, if they are based on SPICE or not. I'm sure the developers have learned from SPICE anyway. The one that's called Falstad Circuit Simulator, and the other one, Quite Universal Circuit Simulator, and the third one we'll probably use is called DishSim. Now, all of these are available through the resource web page from our course website. Okay, so this is the resource web page, and all of them are available through here. You notice there is also a SPICE download, and that's very much the original SPICE, a command prompt SPICE program. Now, We'll use Felstat Circuit Simulator for simple circuits, and I'll discuss it in a separate recording. I'll show you where we download it, and I'll show you examples on how to use it. Quite universal. Let me say one more thing. Felstat Circuit Simulator is a Java application. You can run it online on the web, or you can download it and run a jar. I personally advise you to run the jar because it will make things a little easier for you. And of course it can run, since it's a Java application, it should run on all platforms. Quite Universal Circuit Simulators, or QUCS for short, it's a more intricate simulation. There are many components that you can that are included as part of the simulation. Many commercially available components that are available. You can import more. You can actually add to the program the specs of some of the components. Now it is a little bit more intricate to use than the first one, but then it is one simulator that allows us to do more intricate tests. This sim is very much like Felstat Circuit Simulator, and it works, but actually it runs on the web, and it works just for digital simulations. So it's limited, and it works for just digital simulation.